Okay, this is the second lecture for Chapter 19, and we're looking at smog, photochemical smog at the moment, and just a couple examples here looking at Mexico City. This one here I believe is Mexico City, just kind of showing what happens on these dry, warm days, lots of car, a lot of motor traffic, and this is the result of getting photochemical smog, and this is what I was trying to spit out early. Peroxyacyl nitrates. PANs typically is what they're called, and it's just a product. It's another respiratory irritant that is produced and is part of smog. So slightly different. This one is industrial smog, exact same idea, but one of the major components is going to be sulfur, and this comes from the lack of proper treatment of sulfur-containing compounds, coal burning for electricity generation. So if you don't have some of these industrial filters or particulate scrubbers in place, you can end up with this situation. So here's one little picture of Beijing and London. London's in there somewhere. But again, not treating your particulate to come out of a coal burning factory, this is the result, is you end up with all the sulfur particles that get out there. But there is a treatment that we do pretty well here in the United States, and we'll talk about that one a little bit later on. So this is a particular location, 3 countries, Germany, Poland, and the Czech Republic, where they have typically had some pretty high sulfur content, and it comes from the fuels that they use, which is brown coal or lignite, and it's got a really high sulfur content, and again, if it's not treated properly, you end up with a lot of smog. So radon, we'll talk about this in pretty good detail in class, but radon is completely natural. It's not someone going out and contaminating your soil. You have uranium in your soil, and if you do, and there's a certain good chance that a lot of people do, then you potentially are going to have radon, because radon is a product of the decay of uranium. And it's just a pass-through element. It only lasts for about 4 days or so, and then it goes away. But it's continuous, so it's not like it's a temporary problem. So we'll talk about this in pretty good detail in class. And why is it a concern? Because it is found in pretty high concentration, real close to Michigan. So it's actually just on the outside, like in Washtenaw County, as far as the high level. But still, I would have my house checked, absolutely. And primarily it's in your lower levels, so it's a very heavy gas. If you look at your periodic tables in the bottom right hand corner, and it accumulates in your basement. So if you don't have it vented, you have high concentrations of this, and it's the second leading cause of lung cancer in the United States. Interesting. And this is a good thing. If you look at the United States, you look at all these different contaminants from 1990 on, and look, they're all going down, which is excellent. Maybe ozone's still fairly high, but for the most part, you look at all these different contaminants, and we're all moving in the right direction. So good news. This little slide here just kind of shows some of the major contributors to some of the different pollutants. I won't spend any time in this. You can pause and take a look on your own. Temperature inversion. How do we get this smog? Why does Los Angeles and Mexico City have bigger problems than Detroit does? It has to do with how air gets trapped in their city. I think it's only on this slide. Let me take a look. Yeah, it's only on this one. So looking at a city that is kind of landlocked or trapped between mountains, let's just say Los Angeles, it's in a valley, they naturally are going to have warm air rising. But eventually, if they don't have a flow of air going through there, that warm air is going to eventually just kind of sit up here and form almost a cap. And therefore, the air down here is just kind of stuck, and eventually it builds up. And until you get some heavy winds coming through, or any kind of winds, or it rains, you're going to have smog. And that's what happens in some of those cities, is the air just kind of gets stale, unlike some areas where they have an ocean breeze coming through and it treats it, and they're better off for it. And this just kind of shows the acid rain, and we've seen this before, where you have sulfur and nitrogen oxides mixing with water and forming sulfuric acid and nitric acid. And of course that falls someplace else. So that's the nice thing about acid rain, is you make it, but it's somebody else's problem. So, okay. One thing just to note is rainwater naturally has a pH less than 7, so rainwater is naturally acidic, and that is because it naturally has some carbon dioxide within it, and carbon dioxide plus some water will give us carbonic acid, which is an acid. Okay. And this just kind of shows the natural pH levels. So we can kind of see as far as, places that have coal burning power plants, where are they located, the red dots, and what are the pH levels further on the east. So the natural winds flow from west towards east. So again, acid deposition is somebody else's problem. But we got to deal with Chicago's, so that's why we're in the red, or excuse me, the yellow anyways. Okay, indoor pollution. That's something that we don't think enough about. Obviously in the wintertime we spend a great deal of time indoors, but it's not something that's really regulated, at least as far as your private home. But there's a lot of things that you can take in which can do a lot of harm to you. It's actually a bigger deal to most of us than an outdoor air pollution. So for just the obvious, cigarette smoke is a huge contaminant, indoor air. Formaldehyde comes with a lot of our plastics or carpetings, or I guess a variety of other things we can take into our house. Radon gas, we mentioned that earlier. And then just small particulate matter. Who's the most susceptible? Little guys, kids under 5, because pound per pound they're just more susceptible to the amount of air they take in for the size that they are. Least susceptible would be adult males, just because of their size. Asbestos, we don't use it necessarily anymore, but it doesn't mean it's not in place. And as long as it's left alone and it's sealed off, it's not necessarily a concern. But when people go in and they start stirring it up and removing it, it becomes airborne, and if you breathe it in, you can have some serious respiratory problems. Mesothelioma. So there, I said it. But it is something that was used as far as an insulator for a really long time. Okay, moving on. Carbon monoxide, we mentioned this earlier. Yes, it's outdoors, but when it really becomes a problem is when it's trapped indoors and you have it in there. So it's something that people have to have either monitors to make sure they don't have it in there. You don't smell it, you can't see it, it's colorless. But what it does is it ties up your hemoglobin, and therefore it can't take in oxygen, and you fall asleep and potentially don't wake up. So it's something that you want to make sure, one, your house has a air exchange of some kind or another, and two, that your furnace is working properly and it's combusting completely, so you're getting carbon dioxide and not carbon monoxide. VOCs we mentioned a little bit early on. Usually, if the classic thing you look at is when you buy paints. Oil-based paints typically had a lot of VOCs in them because they were more oil-based. But now, pretty much, primarily, if you buy paint, they're considered water-based and they have low VOCs. If you look on the label, they'll typically tell you that they're low VOCs, volatile organic compounds. And they don't have as many things as like formaldehyde. So you don't have some of these really nasty things in there that can do harm. All right, I guess we don't hear too much about this, but again, because we don't necessarily regulate indoor air as much as we should, because someone, of course, would have to pay for it. But there's a lot of buildings out there that people, get sick in, and there doesn't really seem to be enough enforcement to protect people. But according to the EPA, 15% of all commercial buildings are classified as sick. That's a big deal. That's a lot of buildings and a lot of people that work in these conditions that are classified as sick. So it may not be something that you realize, acutely that you're in work and you feel the sickness, but over a long period of time, it could turn into something chronic that you develop over a long period of time. Okay, good place to take a stop. This is the end of the second lecture, and we'll start number 3 shortly.